Okay, this is a recap of lesson 3.2. Now, just a reminder, we don't do 3.1 in this course, and this is based off the textbook, so we're not using 3.1. So we'll start here, and also remember these recaps are in no way a replacement for the in-class lessons. So today we're talking about polynomial functions and their graphs. Now we've worked with polynomials many times before. You know, polynomial is something like x squared plus 2x plus 1, x cubed minus 4, something like that. Alright, so this is a no calculator chapter because all the work we're doing, we don't need a calculator to do. So today we're looking at graphing without a calculator. So the first thing we need to look at is in behavior. That's the first piece. So in behavior is exactly what it sounds like. It is the behavior of the function at the end of the graph. What is it doing? So you can read through all of this math jargon, but essentially what they're saying is, okay, as you move left, what's happening to the graph? Is it going up? Is it going down? As you move right, same thing, up or down. But the really important part is right here. The end behavior is determined by the degree of the polynomial. And remember, the degree is the highest exponent when it's written in standard form. Okay, so in order to be able to do this, we have to look at a few examples. So your degree can be even or odd. And to figure out what that looks like, we base it off of the two most basic polynomials. So x squared, that's the first example. That would be an even degree because the degree is 2. Well, x squared, we know, looks something like this. Okay? And if we were to instead have negative x squared, all it would do is reflect over the x-axis and look something like that. So in this case, the end behavior is either from the top to the top or from the bottom to the bottom. So it's going up, going down, going down. Now if we change that to be an odd exponent, an odd degree, we can look at y equals x cubed. Y equals x cubed has an odd degree, and the parent function looks like that. So now it goes down and then up. And if we were to reflect that to make it negative x cubed, again it would reflect, but now it's decreasing. So it's either going up or down here. And if you look at the bottom here, it's just a description, like mathematically, as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. Okay, so we're going to put that all together in a nice little chart. So what we looked at first was an even degree polynomial. Now, what you have to decide is, okay, is it even and then is it positive or negative? So if it was positive, it followed x squared. So the end behavior, it was from the top to the top. It started in the top, it ended at the top. Okay? And if you look at it quadrant-wise, it like starts in quadrant 2 and ends in quadrant 1. And then when we made it negative, we flipped it over and it went from the bottom to the bottom. So it started in quadrant 3 and ended in quadrant 4. Then when we went to x cubed, that's the positive version. So it went from the bottom to the top. So starts in quadrant 3, ends in quadrant 1. And when we reflected that one, it was the opposite. Bottom to top, or top to bottom. I'm writing it and I'm reading it wrong. Top to bottom, like this. So it started in quadrant 2, ended in quadrant 4. So that's the first piece you need to know. Second piece, you need to know the zeros of the polynomials. A zero is just a root or an x-intercept or a factor. All of those words are synonyms. They mean the same thing. So The 0 is where it crosses the x-axis. And that's important to know for the graph so you have a definitive point, because without a calculator, this is a very rough sketch of a graph because you can't be super accurate if you don't know all the numbers. But this gives us a definitive point. All right, and to do that, we're going to factor and solve. All right, and the third piece is the multiplicity of the root. Now, the multiplicity is kind of like the degree, except it's like the degree of the factors. What happens is you're going to factor the problem, and then you're going to look at the exponent on the factor, and that is going to give you the multiplicity. Every factor has its own multiplicity, and that's going to make more sense when you see an actual problem. But for the multiplicity portion, you need to know that if f of x equals x squared, okay, and it says what does it do at 0? Well, we know it looks like this. Well, what happens is it doesn't cross through the x-axis. It just touches the x-axis and goes away. So we can say it bounces or it touches. Either way. Versus when it's x cubed, looks like that. Well, now you're crossing through the x-axis. So when the multiplicity is odd, it's going to go through the axis, or we can say cross. Okay, so putting them all together, these are the steps we should be following. So first, what's the degree of the polynomial? Is it even or odd? Is the leading coefficient positive or negative? That's going to give us end behavior. So we can determine where do we start, where do we stop. Then we find the zeros, which is going to give us all the x-intercepts. Then we find the multiplicity of each zero, so we know what to do when we approach those x-intercepts. And then sometimes we look at y-intercepts, not always, because it's not super accurate. I mean, for us, we're not doing an accurate thing. The y-intercept is an accurate point, but we don't always need that. But that also gives you another point of reference to make sure you're graphing it correctly. Alright, so here's our first example. So they've given us a function, negative x plus 3 squared times x minus 1 cubed. And we're going to follow through these steps. So first step is to find the end behavior. So we need to know what the degree is. Well, the degree is the highest exponent when it's written in standard form. So in this case, you have x plus 3 squared, x minus 1 cubed. That's not in standard form, that's in factored form, which is helpful later. But for the degree, if it's in factored form, we have to add those exponents together to give us a degree of 5. Now, that's important because sometimes your individual degrees are not going to be the even or odd number that you need for the whole one. So make sure if it's factored, you add all those exponents. Because if you were to turn this into standard form, you would end up with x to the 5th. Don't waste your time actually doing it though. So we have an odd degree and a leading coefficient that is negative. So it's odd and negative. So what that means, I'm going to start it here. That means it's going to follow negative x cubed. So it's going to start in quadrant 2 and end in quadrant 4. And I'm going to go ahead and mark them so I can follow along. Step 2 was to identify the roots. And those roots come from the parentheses here. It's factored. So if you were to solve both of those, it would give you negative 3 and positive 1. So we can go ahead and plot those on the graph. And I'm only going to put those tick marks because I'm lazy. And I don't need to do 10 tick marks for 3 little things. So those are my x-intercepts. So I'm going to start here, somehow cross through these, and end up here. Now the crossing portion, that's where the multiplicity comes in. The multiplicity is based on the factor itself. So at negative 3, it came from this factor. That multiplicity is 2 because it's x plus 3 squared. So negative 3 has an even multiplicity, which means it's going to touch the graph. So right here, you're not going to cross. Now, 1, that has an odd multiplicity. That's going to cross. So what that looks like, we're going to start up here in quadrant 3. we're just going to touch this point. So we're going to do something like that. And then we're going to go up. Now, I don't care how far you go up. If we found the y-intercept, we could have something a little bit more accurate. But sometimes the y-intercept is like 200, so we're not doing that. We're going to go up however much we want, and then when we get to this point, that one crosses. Cross through, add arrows to the ends. That's my graph. And I can check. I started and ended in the right place. So that means I should be pretty accurate with my multiplicities. Alright, so number 2, we're going to do the same thing. I'm going to start off with a graph. And then we're going to go through the steps. So step 1, I need to find the degree. Now this one is in standard form. So the degree is just 4. Take the highest one. So the degree is even. And the leading coefficient, there's nothing in front, that's a 1, so it's positive. So even positive is going to look like x squared, which means we're going to start in quadrant 2 and in quadrant 1. Now, now I need to look at my zeros. This one is not factored, so we need to go ahead and factor it. So first, I can take out an x squared. And when I do that, I'm left with a quadratic. And then I can go ahead and factor that quadratic with whatever method I need, which, minus 2, minus 1. And that's what's going to factor to. So I'm going to have 3 zeros. I'm going to have 0, 2, 1. So I'm going to go ahead and mark those on my graph. 0, 1, 2. And then for the actual multiplicity portion, at 0 we're going to touch because it's even, but these two have 1s, so they're going to cross. So we're going to start up here, touch, cross, cross, and I ended up where I need to, so that graph is done. Alright, one more example like that. Again in standard form, so the degree is odd, leading coefficient is positive. Odd positive looks like x cubed, so start in 3, end in 1. Now to find the zeros of this one, it's cubic, so we need to factor by grouping. So x squared comes out of the first set, leaving me with x plus 2. Negative 4 comes out of the second set, also leaving me with x plus 2, which is how I know it works. And again, we're at the point where you have not learned how to factor anything that's cubic or above without factoring by grouping. So it should still factor by grouping. And then when I take out the x plus 2, I'm left with the x squared minus 4. Now, it looks done, but don't forget, x squared minus 4 is a difference of squares. So x plus 2x minus 2. Now, that's important because look, you have 2x plus 2's. You have to put them together because here they're to the first power, here they're to the second power. That changes the multiplicity. So my x-intercepts are 2 and negative 2. But the negative 2 has an even multiplicity. The 2 has an odd. So touch, cross. So start here. Touch, cross. And there we go.